Welcome to Chapter 9, Quasi-Experimental and Single-Case Experimental Design. Again, just a quick reminder that these videos is to help you understand the key concept of that chapter. I still highly recommend you read the chapter yourself as well before watching these videos. Without further ado, let's get into the Chapter 9. So we talked about in chapter 8 we talked about two ways to do the study, the research design. One is the survey-based type of design, and the other one is the correlational type of studies. In this chapter, we're going to talk about quasi-experiment and the single-case experiment. So another two different ways to also conduct your studies. Okay, this is the chapter outline. The first part we're going to talk about is quasi-experimental design. Quasi-experimental design is similar to a full-blown experimental design. When we talk about experiment, what that means is to show there is a cause and effect of one variable to another. There's one variable is causing the other variables. Remember, in correlation studies, it doesn't mean that it actually have a cause and effect. It just means that when one goes up, the other one, have more likely could go up as well. But it's not a definite thing that there's one is causing the other to happen. Okay, but in this one, that you could say with quasi-experiment that things are more likely could cause one thing happen to the other. There's a difference between the Lego experimental design and the quasi. In quasi, the participant is not picked randomly. That there's certain pre-existing variables with these participants. Could be age group, could be gender, could be, like, let's say you just want to study men. That would be a quasi-experiment because you not randomly pick a participant from the population. You only specifically pick men. Or let's say you want to study obesity, so you specifically pick people who have obesities. You disregard the other groups. So these are what we call the pre-existing variables. So when you do that, you actually you're not truly doing experimental design. You do a somewhat quasi, I mean it's like perhaps halfway experimental design. Okay. This is there's different type of quasi-experiment. The first one we're going to talk about is what we call one group post-test only design. So let's say you pick a student, let's say a student in the Psych 212, and what you want to see is whether the teaching style that I teach, online teaching style, whether it's effective or not. So you could actually just have them test at the end. Only one specific group. We're not really testing any type of teaching, but specifically to Psych 212. So that would be a quasi-experimental design. And then we look at the exam score at the end of the class, only at the end of the class. Okay, as you can see, the disadvantage could be that there's no comparison group. There's nothing to compare with. You just kind of take the test at the end to see how well they know. Let's say this could create a lot of bias because let's say someone could be a genius, could be very smart. They might have known these information before, so by testing them just at the end, we don't truly know that the method that we teach is truly actually work. The lecture that we give out truly work because we don't have the baseline to compare with. So therefore, the other type of test is called one group pre-test and post-test design. So we actually create a pre-test to see the baseline of that one group, and then we take the post-test as well to see the end result. The advantage is we could now compare the baseline and the treatment to see whether actually the treatment works. However, there's not really you don't have any control group that you comparing with. You just compare it by itself. You're not sure whether that is truly because of the therapy or the treatment that actually works, or because just because of the way the group is. You have a lot of smart people in the group. You have a lot of dedicated people in the group, so they improve their test score automatically. So again, the other group that we have for quasi is called non-equivalent control group. Non-equivalent control group. Again, it's not randomly assigned. These groups are not randomly assigned. There's not does not have random assignment for this participant. And that's the key term to you to remember. That is set. This is what to set the difference between the experimental group versus the quasi-experimental design. Okay, so now you're gonna have two groups. You can have non-equivalent control group. Okay, non-equivalent control group. So now you're introducing the control group into the treatment. Okay, so you could have a non-equivalent control group post-test only design, just like the first one, but with the control group. Now to compare with, so now you could compare the two group with the test group versus the control group to see whether your lecture again works or not. However, you because it's not randomly selected, so the disadvantage could be that there might be biases, or there might be difference of the group to begin with. Let's say the control group could be a very smart group. The test group could be actually horrible at test group. The test score would be show a big difference. Okay. So the next one is like the second one, which is the non-equivalent control group pre-test and post-test. So just like the pre-test and post-test group before, but now we actually have a control group to compare with. Now we could compare the baseline score from the beginning and also compare the test score toward the treatment after the treatment as well. Okay. Again, the only disadvantage would be that it's not randomly selected. That your participant is is selected prior due to certain condition or pre-existing condition that variables that they have. So you can only apply that to the general public, overall public. Okay. Another famous test we often do along with the quasi experiment is called basic time series design. Basic time series design. This is to basically testing the point. Different point in time in one group. So you have one group after the treatment. Let's say you want to treat it 5 minutes, 10 minutes, 15 minutes. Or we could talk about a long period of time. Could be 2 weeks, 5 weeks, 4 weeks, 6 weeks, 8 weeks, 12 weeks. So we could see how the test actually lasts, how long the effects of the test last by looking at these time design. The advantage is you see a snapshot of each treatment throughout the time of how is the time actually affects that. Again, disadvantage, since it's by itself, you don't have any compare group. You don't have any pre-test to decide to see. You're just kind of observing at the end throughout the time. Okay. You also have the interrupted series design, and you can also have control time series design as well. Interrupted time series is the key word for you to remember is naturally occur. Okay, we observe a treatment that naturally occur in the group. Okay, naturally occur type of treatment. There's an example on the next page, I believe. So you're looking here, looking at the hospital admission rates over the years. So naturally, we don't force people to go into the hospital. So you going naturally occur, and then we look at those the time for each year to see how number of admission per population, whether it go up or go down. Interestingly enough, the graph here show that seems like there's a correlation between Bowling Green, Ohio versus Kent, Ohio. When certain year number actually are opposite, certain year number reflecting the same. As it go up, the other one go up as well. The other one is called control time series design. This is basically you have the quasi experiment research that actually have the control group as well with the time series. So you actually combine the time series with another control group, and then see whether one does have the treatment variables, the other one does not, and then see which how often, compare between the two of them, which one occur more often. And then this graph, this table you actually have in your PowerPoint, and kind of explain, kind of summarize what I just mentioned to you the past 10 minutes. The other type of design is called longitudinal design. This is done for a very long time, over a long period of time. I'm talking about 5, 10, 20, 15, 20 years, to see whether what's going on with the population, with the people throughout those years. Could be like you study from the beginning of the college all the way at the end until you actually graduate, or high school, or even from kindergarten all the way to high school, to see the differences. Okay. Cross-sectional designers mean you testing with different cohort, looking at different culture, different aspect, looking at all the possibility from different characteristic. So you testing across multicultural. Cohort sequential design, that's looking at certain cross-sectional technique over time. Okay, looking cross-sectional but over time, so even longer as well. Example, now you probably have heard these, looking at the people across different generations. So like my group, I'm actually in Generation X, who are usually born in 1970s all the way through 1982, 83. Millennials would be people who were born in 1984, 83, 84, all the way to 90s, mid of 90s. Generation Z, which is the current generation, which is born from 1995 all the way through 2010, 2012, somewhere around there. So you could see the differences between each group is generations. Millennials also consider Generation Y as well, the other term that you might have heard. So, a reminder, kids, you might want to give them assent, which is a consent from the parents as well. Single case experiment, usually these are the kind of rare cases, because you have certain things that you want to test. People who have certain disease like Parkinson or Huntington disease or ALS, all of those are special cases. Or people we had with DID or depression, like severe depression, those kind of things. You want to do randomize picking those people, but they have certain conditions that come with them already. So technically we consider that more like a quasi-experimental. But we only do with 1 or 2 people and then test them, manipulating with different treatment, different tests to see whether which one works. One of the famous design is called ABA. ABA doesn't really stand for anything. It's just A referring to the first phase of the study, and B is referring to the treatment phase, and then hopefully after you stop the treatment phase, then it would go back to that baseline phase of A again. So the graph would look like this, would be flat at first and then goes up, flat, and then goes down as well. So when you go into those phases. Single case baseline, so you actually find a baseline first before you apply the treatment, basically what that's saying. And you could actually introduce more than one type of treatment. You could do the baseline, and you could do treatment 1, wait for a little bit of time, do treatment 2, wait for a little bit of time, do treatment 3. The recommendation is to end your study with the best treatment. So whichever one that the patient responds best, you would actually end with that one. Okay. That's pretty much the summary, the quick summary of chapter 9. Thank you for watching, and I'll see you in the next one.